Have you ever wondered how our world came into existence? Let's take a journey back in time to the very dawn of creation, where everything we know and understand about our universe began. Picture a point of infinite density and temperature, a singularity where laws of physics as we understand them cease to exist. This is the Big Bang Theory, the most widely accepted explanation for the beginnings of our universe. Imagine the singularity, an entity so small and dense that it's impossible to comprehend. Then, in an instant, it explodes. This is not an explosion in the traditional sense, but rather a rapid expansion, as if the universe itself were a balloon inflating at an incredible speed. As our universe rapidly expanded, it also began to cool. It's a bit like when you open a can of soda. The released pressure allows the liquid to cool down. In the case of our universe, this cooling allowed for the formation of the most basic building blocks of matter, quarks and electrons. These particles were so hot and energetic that they existed in a state of plasma, constantly colliding and interacting. But as the universe continued to expand and cool, these particles began to slow down and combine to form atoms. Atoms are the building blocks of matter, the ingredients of everything we see around us. And as these atoms began to form, they started creating the foundation for the next stage of our universe's evolution, the formation of stars and galaxies. Picture a cloud of hydrogen and helium atoms floating in the vast expanse of the early universe. Over millions of years, gravity pulls these atoms together, creating a dense core. As more and more atoms are pulled in, the core becomes so dense and hot that nuclear fusion ignites, and a star is born. These stars, through their life and death, create the heavier elements needed for planets and life as we know it. They cluster together to form galaxies, vast cosmic cities teeming with stars, planets, and potentially life. And so, from a singularity, the universe as we know it began to take shape. But how did our Earth, a mere speck in the cosmos, come to be? Let's rewind the cosmic clock back around 4.5 billion years to a time when the universe was an unimaginably hot, dense expanse. Our solar system was but a swirling disk of gas and dust spinning around a young and tumultuous sun. In this cosmic whirlpool, particles began to collide and stick together. Over eons, these particles grew, forming planetesimals, the building blocks of planets. Among these embryonic celestial bodies was the one destined to become Earth. Initially, our planet was a seething, molten mass, bombarded continuously by other space rocks, growing bigger and hotter with each impact. But nothing remains the same in this ever-changing universe. As millions of years passed, the Earth began to cool. Its exterior hardened into a thin crust. Water vapor released from the planet's interior and delivered by icy comets condensed and fell as rain. Over time, this process created the Earth's oceans, a significant milestone in our planet's history. The stage was set, but the main characters were yet to make their entrance. Life as we know it began in these watery cradles. The first inhabitants were simple, single-celled organisms, but life is tenacious and innovative. Over billions of years, these microscopic life forms evolved. Growing in complexity, they learned to harness the power of the sun, filled the atmosphere with oxygen, and paved the way for more complex organisms. From these humble beginnings, life on Earth exploded in diversity and complexity. Cells grouped together to form multicellular organisms. Organisms joined together to form ecosystems. Over time, the Earth transformed from a barren rock to a vibrant, living world, teeming with life in an array of shapes, sizes, and colors. The story of Earth's evolution is a testament to the power of time and the relentless march of change. From a molten rock spinning in the void, our planet has become a lush blue oasis, a beacon of life in the cosmic desert. The Earth, once a fiery ball of rock, became a cradle for life. Yet despite our understanding, many mysteries remain. For instance, are we alone in the universe? In our relentless pursuit of knowledge, we have turned our gaze to the stars. Not content with understanding our own world, we look outward, to the infinite expanse of the cosmos in search of answers. One of the most pressing questions in this quest is the existence of extraterrestrial life. Are we, the inhabitants of this blue-green jewel we call Earth, the only sentient beings in the universe? The search for extraterrestrial life has taken on a new and exciting dimension with the discovery of exoplanets, planets that exist outside our solar system. Some of these celestial bodies reside in what scientists call the Goldilocks zone, a region around a star where conditions might just be just right for life as we know it. These discoveries tantalize us with the possibility that we might not be alone, but as yet, we have no definitive proof. Then there are the unidentified flying objects, or UFOs, those elusive phenomena that have sparked curiosity, excitement, and fear in equal measure. Despite numerous sightings and anecdotes, concrete evidence of their origin and purpose remains elusive. Some believe these are advanced spacecraft from distant civilizations, while others propose more earthly explanations. Yet the question remains, what are they? Where do they come from? This brings us to the Fermi paradox, named after physicist Enrico Fermi. It's a contradiction that has puzzled scientists for decades. If there are a multitude of stars in the galaxy similar to our sun, with many of them likely having planets similar to Earth, where is everybody? If extraterrestrial life is as probable as we think, why haven't we made contact, or why haven't they contacted us? Some propose that maybe we're not listening properly or we're not interesting enough to warrant attention. Others suggest that perhaps civilizations self-destruct before they become technologically advanced enough to communicate across the cosmos. And then there are those who believe that we have been visited, but the evidence has been suppressed. Regardless of the truth, the search continues. Astronomers scan the skies, researchers crunch data, and dreamers look up at the stars, all in the hope of finding an answer. It's a question that transcends science, delving into philosophy, religion, and our very perception of ourselves in the grand scheme of the cosmos. So are we alone in the universe? Despite our best efforts and our most advanced technology, we still don't have an answer. But the quest for that answer, the journey of discovery, is in many ways just as important as the destination itself. It propels us forward, fuels our curiosity, and reminds us that no matter how much we learn, there will always be mysteries to unravel. The question of whether we are alone in the universe remains one of our most profound mysteries. So what lies ahead for our world and its inhabitants? As we stand on the precipice of the future, we can't help but wonder about the potential directions our world might take. We're pushing boundaries like never before, and with each stride into the unknown, we're reshaping our reality and redefining the limits of what's possible. Consider the leaps and bounds we've made in technology. From the first computers that filled entire rooms to handheld devices with more processing power than early space shuttles, we've come a long way, and we're not stopping. Artificial intelligence, nanotechnology, biotechnology, quantum computing, these aren't just buzzwords, they're the cornerstones of our future. They're the tools we'll use to solve problems, to innovate, and to continue our journey into the unknown. And speaking of journeys into the unknown, let's talk about space. It's the final frontier, the next step in our journey as a species. We've landed on the moon, we've sent rovers to Mars, and we're beginning to seriously consider the possibility of colonizing other planets. But as we reach out into the cosmos, we're also reaching out to potential extraterrestrial life. The existence of aliens, once a topic relegated to science fiction, is now a serious scientific pursuit. If we were to discover extraterrestrial life, what would that mean for humanity? Would it change our understanding of our place in the universe? Would it unite us as a species, reminding us that we're all inhabitants of this tiny blue dot in the vast expanse of space? The possibilities are as endless as they are exciting. But while we're reaching for the stars, we're also grappling with the realities of our changing planet. Climate change is one of the most pressing issues of our time, and it's a challenge we'll continue to face in the future. But it's also a catalyst for innovation. From renewable energy to sustainable agriculture, we're finding new ways to live in harmony with our planet. And as we do, we're not just preserving our world for future generations, we're also paving the way for a future where we live in balance with nature. The future is a kaleidoscope of possibilities, a tapestry woven from threads of potential and uncertainty. It's a world of flying cars and smart cities, of space travel and alien encounters. It's a world of challenges and opportunities, of problems to solve and mysteries to unravel. As we look to the future, we continue to seek answers to our questions, driven by our insatiable curiosity about our world and the universe beyond. Our journey is far from over. In fact, it's just beginning. And as we step into the future, we do so with the same sense of wonder and thirst for knowledge that has propelled us from the dawn of creation to the edge of tomorrow.